not, something that we always discuss when it comes to raw performance, because being a car enthusiast myself, if you were to give me an option, between the most comfortable car and car with a monster engine in there, and just the basic necessities, one seat, one steering wheel, and an engine, I would be more than happy, because that goes fast, and I would enjoy that. But when we are talking about everyday applications, we need to even consider noise, NVH, that we call noise, harshness, and vibration, which is very, very important for people, for normal people who are not car enthusiasts, who use vehicles for, transportation primarily, and they do not want any kind of interruption. They want a really silent, quiet journey where, if they go out on a long drive, they can enjoy music, they can enjoy with their family, and that's all. So that's where NVH levels also come in, and that's where EV is taking, leaps and bounds in the technology. So now coming to structural member. Okay, so let me give you a brief explanation of what, how is a battery used as a structural member. Does anyone have any idea what a structural member in a vehicle actually is? If someone does, please unmute and speak. Or you could use the chat. Yeah.
Members of the chassis.
Frame.
Yes. How would a battery be the member of the chassis? Okay. So basically, if anyone is a motorcycle enthusiast over here, okay, mounted on the chassis, okay, Rohit, you're getting close. So if you are a motorcycle enthusiast, you may have seen the difference between a Splendor and a 1000cc superbike. So, or a 600. So basically, the idea over there is something called as a double cradle frame chassis in motorcycles. That is. Now, how does that work? I'll show you. So you have something like this. Okay, your engine sits over here in a bike, and here you'll have your steering arrangement and stuff like that. So now this double cradle frame chassis basically supports battery pack itself, can be considered as a structural member. Exactly. So yeah, so this double cradle frame chassis, what it does is it is a complete member. That chassis can take loads in all direction. But the problem with that is the weight of the vehicle increases at the end of the day if you are going to add that extra member. But when you take a bigger engine which is properly and solidly built, you can use that engine itself as a load member, where the engine helps the frame stabilize itself. So that's where you have the idea of using powertrain components as structural member kick in. So in EV, in the electronic vehicle, what we do is the battery is really huge. It has most of the weight, and it's a very rigid component, right? So what we can do is we can start loading it to a certain degree, because the outer casing of the battery is really strong and rigid, so it can take the loads. So if you see over here on the right, you have a traditional ladder frame chassis that we see in most modern pickups and tempos and stuff like that. And to your left, you will see the EV chassis. Now, if you can see over here, you've got a lot of cross members that run through in this typical H frame or ladder frame type chassis. Now, these cross members are not light components. They are extremely heavy. Total, if you were to just take the weight of that, you would be nearing somewhere around 90 to 100 kilos, just because the cross members that run between the two ladders. However, over here, when you are going to use a battery pack, it can be used as a cross member itself, and it can be used to take the load. So what happens with that? Now, rear wheel drive vehicles, if you see, which we have a lot of them, they generally you have a configuration in IC engines called an FR configuration. FR means a front engine, a rear wheel drive this combination. Now, this is seen in many sports cars, many road going cars as well, where you have your engine in the front, you have a drive shaft, then you have your differential, and it sends power to the rear wheel, right? But electric motor is completely different. You can have the battery at one corner of the car and power the the extreme end of the car with no issues. You can have motor running in all four wheels if you want. You can have a motor running in the front two wheels. You can have a motor running in the rear two wheels. But with EV, we have this added advantage. If you were to put the battery in the floor of the vehicle, right, and add the motors to the rear, the front of the vehicle is completely empty. What do you do with the front? As you can see over here, it can be used as a crumple zone. So what is basically a crumple zone? Now, we all know that a machine needs to keep the human safe, right? So whenever you see a vehicle, Maruti Baleno got a lot of slack for this in the starting days. In fact, all the Nexa models got a lot of slack for it. For when a small accident would take place where a Baleno would, just crash into some normal vehicle and it would get crumpled completely. The entire front would collapse in. And that was where people were like, they were confused because we had never seen vehicles like that. We had never seen vehicles behave like that, where the entire front of the vehicle deforms. But that is very essential. We want the car to deform and take as much as force, as much as energy as it can absorb from an accident and prevent it from entering the cabin. But now, if you're looking at the traditional combination that we see on the Indian roads, the most common, almost 80 to 85% or even higher percentage of that of vehicles are an FF combination vehicle, where you have a front engine, front wheel drive. So you have everything in the front, right? You have your engine, you have your you have your gearbox, you have your differential, you have your what do you call drivetrain, you have your steering wheel. Everything is mounted in the front. The rear of the car does not have anything, right? What happens over here is when this car gets into a crash, if the crash is extremely, it's a very powerful crash where there was a lot of energy, there is only a limited space where you can dissipate this energy. Now, I'll just show you GIF where you'll get a fair understanding of what I'm talking about. Now, if you see the front part over here, just before the engine, you'll see a good gap where you can see the floor, under the car. Now, that is there for crumpling. But what happens when, that part of the car has crumpled and moved on, and now it touches the engine? You have a solid block, you have a solid iron, or you have a solid aluminum block, which is going to take the entire hit. And when you hit a solid, it either cracks or it either moves, right? So it has happened a lot of times where the heavy engine component got hit real hard, tore through the firewall and entered the passenger cabin in extreme crashes. And that's a very, very bad scenario to occur if you're in the vehicle, and of course if you're the driver or sitting in the co-driver seat. So that all can be avoided by using electric vehicles. How can that be done is over here. Now consider the battery pack to be in the floor of the car. Your motors and driving assembly, everything is going to be in the rear of the vehicle. Your entire front, you're free to do whatever you want over here. You can make it as a storage space with a good structural design out there, where any amount of force. Now, if you could see this diagram a bit more carefully, you will understand that the arrow that this car is taking an impact in, the force is coming head on. But while designing the vehicle, you have to make sure that this force does not go straight in. It dissipates to the sides. Your hood tries to divert the force. If you've seen the internal panel of a hood, whoever has access to vehicles, go and open the hood of your vehicle. You will get to see, mostly there'll be a heat retardant, insulation in there. But if you press your hand against it, you will feel there are cutouts in the hood. So your hood is made out of two panels. You have an outer panel and an inner panel. The inner panel of a hood itself tries to dissipate all of the energy coming in straight towards the hinges, because the hinges are rigid members. They will rip apart and dissipate the energy. Same with the body of your vehicle. The monocoque of your vehicle will try and take as much as an impact as it can. But in EVs, we can make that even more effective, where your vehicle tries and takes 95 to 98% of the impact, and you barely feel it inside the cabin. So it ends up making your vehicle much more safer. Okay, so moving on. Now, we'll talk about load management and center of gravity placement. In an EV, the battery, of course, is the heaviest components. Now, the weight of the battery is also a downside to the vehicle, of course, but it also has its own, perks and benefits. Most of the EVs will have their vehicle on the floor, and that leads to a lower center of gravity. Now, the GIF that you're seeing out here, right? It's called as a moose test. So how this test is performed and why is it performed is basically there was a lot of problems with moose, the animal. It's a huge animal. Yeah. If you've seen cows and buffaloes, multiply that by 1.5. It's a massive animal and it is extremely aggressive. It attacks anything that it sees moving. So, when these people were driving through forests and places like that, these moose would just jump onto the road and try and attack their vehicle head on, or just jump and scare the driver for some reason. So they're like, people have to deflect it, right? You have to take a quick left and a quick right, or whatever way to deflect it. So in a moose test, what's done is a vehicle is taken at different speeds, at 60 miles per hour, 80 miles per hour, 95 miles per hour, and different speeds they have to rate the vehicle, how stable it is. Now, if you can see, this is a Jeep Compass out here, which is one of the better performing SUVs. I couldn't put the other videos because they were actually bad. There were many SUVs that just toppled over. The reason for that is the center of gravity. The center of gravity is too high. If the center of gravity gets too high, the vehicle becomes extremely unstable. So when you try to take a quick left and a quick right through a chicane, or maybe dodging someone on the road, there's a high chance you'll topple your car. And once your car is toppled and it's in motion, you're not the driver anymore. You're not the pilot. You go where the car goes, right? Because it's skidding and rolling and it's doing everything that it can to kill you. So that's why EVs and EV SUVs will be much more safer, because the overall center of gravity of that car is going to be low. The weight of the battery is going to be so heavy that, and placing it that low, what it's going to do is, no matter how many people you load into the vehicle, no matter what's the weight of your cabin, it is not going to outweigh the battery, and this will not be a problem. The car would be much safer at handling something like a moose test. Now, this is another example of Subaru. So Subaru tried to experiment with the Boxer engine. So the Boxer engine is like, just give me a second. So the Boxer engine is something like a trademark of BMW and Porsche. No, Rohit, it's not a rotary engine. It's a Boxer engine. It's completely different. So it's a trademark of Porsche and of BMW motorcycles, that is. So what is a Boxer engine, right? Basically, what it does is, you have your inline engine where all your pistons are firing, something like this in a straight line. A flat 180, exactly, Bhargav. That is a Boxer engine. Then you have your V engines, where you have, cylinders which are firing in V order. So that you would see on Harley Davidson, and when you're talking about car, you'd see it in the Accord, you'd see it in the Nissan GTRs and things like that, where you have the pistons arranged in a V arrangement. But in a Boxer engine, you have it positioned at 180 degrees arrangement. What that does, it is lowers the engine and makes it more like a biscuit kind of, right? More flatter. So what happens when you make an engine flatter is, you can reduce the CG of a vehicle. Now in IC engines, that's the only way you can actually get an engine lower, because of course, there's going to be huge amounts of limitations when you're making a road going vehicle to get an inline six engine that low, or to get a V6 engine that low, because those engines are much taller, right? So that's where these Boxer engines actually fared well, and they did a phenomenal job, and increased and made brought Porsche into the sporting picture, to be honest with that. So this is one thing. So in EVs, again, if we are looking at the battery pack placed at the bottom of the vehicle, this is a all-wheel drive vehicle. This car is going to be much more stable than if you had your engine in the front powering just the rear wheels, or maybe you had a mid-engine all-wheel drive combination, something like the Lamborghini Huracan or something like.
Sir, you are on mute.
Hello, sir.
Yeah. Thanks. Someone decided to mute me for some reason. Yeah. So yeah, what I'm saying is, if you're going to talk about something like the Lamborghini Huracan, where this car has a mid-engine all-wheel drive combination, it's one of the most stable supercars and hypercars that exist. But I could bet you that arrangement like this, where you have your battery and an all-wheel drive combination, would be much more stable. I'm not going to say it's outright faster, because it's not. It will take some time to beat those levels, but yes, it is a very strong competitor, and it's going to be much more stable at higher speeds and around a racetrack as well. Then we come to braking. Now, before we come to braking, does anyone have any questions about what we discussed till now, or any inputs that you would have? Please feel free to unmute and talk.
So one doubt, sir, can we add the same battery weight to the normal IC engine, sir? If we take heavy density material and add it to the bottom place.
Okay, so see, Mohammed, you do not want to make a vehicle heavy. No one is going to intentionally increase the weight of a vehicle, right? Because when you increase the weight, you lose a lot of things. You lose cornering stability. At the same time, you also, of course, you'll sacrifice performance and fuel to a degree which would be sinful at that point. So you do not want to increase the weight. That's a side effect of EVs, and let's say that's a restriction of technology that we have as of now. As of now, the best technology that we have yet makes the car extremely heavy. The Tesla is somewhere around 3,500 pounds. So if you were to, roughly calculate it, you're talking at around 1.8 tons, somewhere around that weight, which is extremely heavy. Yeah. So that's why that's just a side effect which can be used as a positive. So we do not want to increase the weight of the vehicle. And if you're going to tell me if we can incorporate the same dynamics in an IC engine, yes, it can be incorporated to a certain degree. As I told you, when you use a boxer engine, when you
All these
use
things, after doing all these things, you
something
will
where
be
with a
given
mid-engine
certain score. And
combination. So a mid-engine car is basically, you have your driver, you have the front part of your car, you have your driver, and the engine sits exactly behind the driver, right? You have the massive firewall, and then the engine sits exactly behind. So a mid-engine car, the best example would be most of the sports cars that you see today. You see a couple of Ferraris, then you look at the Lamborghini models. They are all mid-engine vehicles. That improves the dynamics, and that's the best, way that a vehicle, an IC engine vehicle, can perform very similar. But of course, the dynamics of an electric vehicle will be much better than IC engine vehicle, because you also do not have that rotating mass in there, which is a topic for another day, completely different, monster to fight, if I were to put it that way, where the rotation of the engine affects a lot of things on your vehicle. Yes, any other questions or any other additions to what we have discussed? Guys, at least unmute and say no, na. So,
Sir, crumpling, sir, what we if we place engine at front, when the crumpling zone happens, the
yeah,
driver gets more damage. But we can
yes,
replace the engine at back or mid, right, sir?
exactly. That is being done, Mohammed.
Yes,
But
sir.
the issue with that is it is not a very cheap thing to do. Now, you tell me how many cars that you see on everyday road have got a mid-engine or a rear engine combination?
Sir, like if we
None.
say if we go back to 2 or 3 years, most of the cars are rear drive engine. But
No,
nowadays we are seeing most of the cars are front wheel engine due to
no. So
energy transfer. Propeller shaft will be reducing, so that the weight will be automatically gets reduced. The end price of the car will be getting reduced, and the power transmission will be smoothly if we place the engine front. So that is a main advantages usually now car manufacturing are practicing, sir.
yeah, so see, one of the biggest reasons, the only other car that I can tell you that was an Indian manufactured car that had a rear engine, rear wheel drive combo was the Tata Nano. Except for that, there is no other car that I have seen with a RR combination or a MR configuration in the Indian market, right? And the biggest reason for that is it is very
Hello, sir.
economical
Good evening.
for a car manufacturer to place the
Sir,
engine
at the
as well
time
as
of
the drive into the front of the vehicle, because everything is one single unit. It's easier to maintain, it is easier to manufacture, and it's very easier to cut costs over there. So, what measures? Okay, so there are a couple of questions. Rohit, I cannot help you with the electric motor. That's not my field of expertise. So, you can always drop in a mail and that question will be answered. Sandeep, would aerodynamic drag and ergonomics of EV are considered according to Indian road conditions? Let's discuss that post everything, like after the seminar has come to a close. We'll discuss that, Sandeep, for sure. What measures have taken into consideration from drivetrain of vehicle for vehicle dynamics of electric? Aditya, can you unmute and ask the question, because I cannot understand what are you trying to convey over here. Hello, Aditya.
So drive shaft we have to for I'm in FFA team of my college.
Yeah.
So for drive shaft for rear knuckle we have to take some consideration. So what things we have to assume or information need about drive shaft for vehicle dynamics design?
Okay, so drive shaft for an IC vehicle you're talking about, right?
No, EV.
Okay,
Electrical.
I would have to read up on that, Aditya. I cannot comment without knowing the rules that you are restricted by as of now, and also the requirements. Just hang around till the end. We will discuss on that as well, on what we can do for that. So, if I'm not wrong, you're restricted to using only one motor if you are forced to use a drive shaft, I'm assuming, right?
Yes, sir.
Okay, okay, got an idea for that. Okay, so let's get back to the PPT for now. Braking. The requirement of braking in an EV is not as strong as a gasoline vehicle. What would, make me boldly state something like that? Because EV has got something called as regenerative braking. Now, regenerative braking is very important because uh, we need to understand that braking essentially is the loss and absolute waste of energy, right? You put in so much amount of gasoline, you made your engine heat up and fire, and got to that particular speed when you're driving an ICE vehicle. Suddenly you realize, people who drive over here will totally understand what I'm saying. You are driving on an open highway, decent speeds, and then suddenly someone just decides to cut you off. You have to brake really hard, kill all of your speed, and then you again accelerate. And that is a very irritating thing to happen, where you gained a good amount of speed, you're comfortable with that speed, and then you had to brake, and then you had to accelerate all over again. Now, that is a huge loss of energy, because acceleration requires a lot of energy. So you put that amount of energy, then you are cruising, and then you have to decelerate hard. So that kind of deceleration, what happens is,
Sorry
let's
for
just
that,
take an
but
example of a
if
disc
you
brake.
guys are
You
not
have a
putting
disc
efforts,
rotating, you have your calipers, you press the brake, you apply brake pressure onto the disc, extreme amount of friction takes place, which results in heat. So the energy that you were carrying, the kinetic energy that you were carrying, is now getting converted into thermal energy because of this friction, and it is being dissipated. So disc brakes are, known because they can cool that quickly, they can dissipate that energy that quickly. But let us stop and consider, do you actually want to dissipate that kind of energy? What if you could use it? So if we are to uh, uh, find a way to use that energy, of course we are not going to lose it. And when you're talking about something like an electric vehicle which takes in electricity, stores it, then uses it for acceleration, what if we could take convert that thermal energy, convert that rotational energy, and convert it into the form of energy that a vehicle can use? And that is all that regenerative braking does. Every time you try to stop, so your motor is not only a motor, it is something like a motor generator unit, or MGU. This idea originated with Formula One, and when Formula One cars started going hybrid and stuff like that, and that's where this technology has been perfected over the years. If you are a fan of Formula One, you would have seen there were massive cars, V10 engine cars, and currently we are only running V6 hybrid engine. So many people were disappointed because they lost the sound of the V10 IC engines. But of course, we need to think about the environment, and that was the right direction for them to go at that time. But how did that benefit us? Because today, most of the cars, most of our EVs, most of our hybrid vehicles, let's not even talk about pure hybrid, let's talk about mild hybrid vehicles. Mild hybrid vehicles, you can take examples of Ciaz, Baleno, a couple of models from Toyota. All these vehicles, they use an IC engine as well as they use a battery, and the battery helps slightly. A slight amount of boost is given to the vehicles. So how it does this is so how this happens is basically when you are moving, you gain speed, whatever, and then you realize you see a traffic signal really far, and you know you have to come to a stop now, right? So you start tapping on the brake. Of course, you're not going to stamp on your brake there and then, right? Because you see it at quite a distance. So you start you fiddling with your brake pedal slightly, as well as you're letting the vehicle coast and lose some amount of energy. Like MGU, okay, yeah, Shiva, I'll get back to you. So you have that, and then your vehicle is coasting and rolling. So the moment you lifted off from your gas pedal, your car started harnessing that energy that it initially put to get itself into motion, as well as when you were slightly tapping on your brake pedal, your MGU or your motor generator unit started charging the battery again. So now this is a good example over here. Now, if you see, acceleration is full and the mode is drive. The moment the acceleration is left, it goes into generation mode. The moment the brake pedal is pressed, many different manufacturers have different ways of configuring it. Many people are against letting the car, start generating the moment you want it to coast, because that will cause it to slow down quicker. And there are many calculations in there. But the basic idea is, whenever you want to get your vehicle to a stop, the most effective way to do that would be to get that energy back and then use it. That will, of course, increase the efficiency of your vehicle. It will, be the best choice for the environment. And yes, there, before anyone could ask me what happens when there's an emergency, that's when you have regular braking systems. So every electronic EV is going to be equipped with a traditional braking system, where you have your brake calipers and all of the arrangements that you have on an IC engine car. You slam on the brake, the car will come to a stop, and that is extremely important, because no matter how much resistance your motor can generate, your braking technology of today is much more safer than just
Prefer
having your
you
motor
when
give
it comes
extreme
to the
amounts of
end
resistance
placement and
and
internship thing.
possibly lock up your wheels, and that could spell disaster. So that's why we prefer using the traditional braking system with EBD as well as ABS. So that will keep the car straight and stable in emergency situations. So Mohit, okay, sorry if I cannot pronounce your name, I'll just call you Shiva. So you asked me whether it's like MGUK, whether onboard battery is charged while brakes are applied, and this can give extra power to the motor. Exactly, it's similar to the MGUK unit. So used in F1, where it's not only during braking, they also can harness it separately. As I was telling, coasting. If you watch F1 right now, you would see lights blinking at the back of the car. That tells the driver behind that the driver in front of them is actually harnessing energy and charging their batteries, because the F1 car batteries are really small and they cannot last for an entire race. So they use the battery sometime, get aggressive, take some overtakes. The moment they find that they have taken a lap quick, they decide to hit the button and harness energy. That's called as harnessing or harvesting also. So that is very, very useful in F1. So next we come to cornering effect and stability. So this is one of my absolute favorite GIFs. If you have attended any other session of mine, you would have seen this GIF come into play, right? So the basic idea over here is this is a classic example of understeer. So what is understeer? Basically, you have your vehicle and your vehicle wants to go straight, right? And there is a one second, just give me a second. Okay. So we consider this to be a
Regarding the
left-hand
course,
turn.
feel free to ask. I will
So
be
now
more
this is
than
a very
happy,
similar
and I will be
scenario
the
to what
person
is
who will be
happening.
interacting
You
with.
took your car, and the ideal route you want is this by your car to follow, right? You wanted to take a left and continue with its trajectory, like continue with the road. But if you are extremely fast, or the weight of your car is too much, you would be susceptible to something called as an understeer. So what happens in an understeer is, in when you reach this position, in your car won't go left, it would rather decide to go something like this and fly off the road. And the another example would be understeer, oversteer. So in an oversteer scenario, you again reach the turn, you turn your car in. If the weight at the rear of your car is too much, or the grip on your rear tires is too little, there are many reasons that cause it, of course, but your rear of your car would step out. So you're trying to take a turn like this, your car would step out, and you would suddenly point in this direction and go over here. Of course, both of these scenarios are not recommended. You do not want any of this to happen. So for that, what you have to do is you have to ensure that your vehicle has got a good amount of stability and can take corners properly. It is wide enough and low enough. So we discussed that we are going to get the battery weight down. The EV is going to be heavy. Now, what does this do is, since the weight is centralized, it is low, the overall effect, the CG, the body roll that we talk about in a car, so that is going to be minimal. So the inertia force which is trying to pull you, the centrifugal force that is trying to pull you away from the apex. The apex of a turn is the centermost point that you hit in a turn on a racetrack. So the forces that are trying to take you away from the apex can be controlled just by having that amount of weight at the bottom of your vehicle, and that increases the stability. So yeah, now here we come to, there's also a point of view about dynamic balancing. So what is dynamic balancing? Is basically, as I told you, you have rotating parts in your IC engine. Now this rotating parts in the engine cause something like,
give it to
you
us
could say
separately.
something like a gyroscopic effect, where you have this
software access you are
entire
talking
weight
about.
doing this inside
Yes,
your
sir.
car, or
Yeah,
maybe it's
so what we will do, Amir,
rotating
is we
like
will
this.
share
So
the
that's why
links
99%
of
of
the
IC
some
engine
student version of
manufacturers
the
try
software.
and
You
place
have
their
to
engines
go through and
uh,
process
diagonally,
the
and they
formalities
don't
on
try
the
to place
website,
it vertically.
like
I
posting
guess
your
I'm
ID card
not
and
using the terms right. I have lost the right term for it. But yes, it's very difficult to dynamically do a dynamic balancing of an IC engine in a car and yet have the stability, because that rotating mass does cause a lot of problems. So yes, now let's come to the next one, which is noise and vibration. Now, okay, someone has sent a- yes, Sandeep, you have a question? Sandeep, you raise your hand. Mm, okay, raise for time pass. Okay, so if you do not have any questions, we'll continue. So now EV, there's a big problem with EVs, right? The first time I came across the idea, I have always been a hardcore petrol head. If you were to ask me, I would run a car straight pipe, I
that
would run a
once
motorcycle straight pipe just to listen
you
to
are
the
enrolled in the program and
the
you
sweet
are
sounds the engine would make when
having
I
going
roll
through
off
the transit.
the throttle, and you have those chines and pops, and if you are running a turbo or something like that, you would have flames shooting out of the back, and that is a very fun aspect. But we need to even take into consideration that the environment is a thing, and we need the environment to be in the best of conditions if we have to have our own generation survive, as well as our future generations to survive. First we need to think about our own generation, because the rate at which we are going, uh, higher possibility that we won't be that cushy at the end of our lives, right? So we need to take care of this environment. So that's why we switch to EV. But the biggest problem with EVs is that these vehicles do not have any kind of sound. They have very bare minimum amounts of sound, which is actually a big problem for people conditioned like us.
Answer one more
So if
question.
we are going to look, we have been conditioned over the years, over 100, 150 years, to anything approaching with a sound. Before cars were even there, we had horse carriages.
Like
When
how
people were
can we
walking on the
bifurcate
road,
our
they could
time
hear the
from our
tuck,
daily
tuck,
life
tuck, 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 tuck
toward
sound
this
of the
course so that we
hooves,
can be like
and
this
they
course will
would
be more
move
effective
aside.
to for us.
Yeah,
Then came
time
the
management.
Time management.
then Benz came out and made, like, Carl's Benz came out, made his car, and that started getting vehicles onto the road. Some amount of vehicles, the engines would have the whirring sound, where people would listen to that and move out of the way. Then Ford came into the picture. I'm sorry, revolutionized the entire automotive domain. Everyone had a car, right from the richest to the most poor of people. But again, those cars had one key thing in common, and that is that all of them made a lot of noise. So I always remember this one thing that my dad always told me about modern cars, right? This is way before I was an engineer myself. I was just a car enthusiast and enjoyed vehicles in general. So the only big gripe he had of modern cars is it's too quiet. So, and his reasoning behind that was the cars are so quiet that a pedestrian cannot hear it approach. And he's talking about IC engine vehicles, today's modern IC engine vehicles. So imagine if that is too quiet for a pedestrian to hear and move out of the way, EVs are going to be much, much more, problematic. Where an EV, you're just walking on the road, and EV would approach you at 100 km per hour and slam into you, and you wouldn't even know, you wouldn't even hear it coming. The maximum that you could hear it is like what, when it's 10 or 20 meters close to you, and that you'll only be able to hear it cut through the wind, and that will be your only indication, and not enough, right? Rather, if you see an IC engine doing 100 km per hour, no matter how quiet it is, you will hear the engine go boom right past you. That's not the case with EVs do have certain amount of sounds, but not much. So that's why we need to, add sounds. And also, being a passionate driver myself, or like any vehicle that I operate, I connect with the vehicle because of its sounds. Every time I would rev an engine, I know which gear I am in, I know which speed I am in, just by feeling the vehicle, right? You feel your engine working hard sometimes. You feel your engine chilling when you're cruising. And those are the tiny things, the vibrations, the sounds, and everything that makes the entire experience possible. But if just imagine this, you open the throttle, you don't listen, you cannot hear anything, you cannot feel anything, but you are going fast because of these years of conditioning that we've had, where our brain associates
Spend
sound and
instead of
vibration
watching,
with
scrolling
speed.
Instagram
Our
and
brain
watching
won't
some kind of web
comprehend
series,
that
just
well,
spare
that we can
half
go
hour,
that
40
fast
minutes, half hour,
while
40
being that
minutes of
quiet.
time on
So
this,
that's
and
why
you will get a
car
best out of it.
manufacturers have come up with sounds.
Yeah,
So
thank
the
you so much for
first
that.
Yeah,
ever
well,
car manufacturer to come up with a sound was BMW. So if people know this
even
vehicle, it's the
want
BMW
to
i8. So this is a car owned by Sachin Tendulkar, also a fun fact.
how many
But the
internships. So
biggest
basically,
thing that
we will
this
be
car has going for it is it's a hybrid vehicle. It has a three-cylinder IC engine in there. But what they did, and it was a very cheeky move by BMW to do it back then. It did this like years ago, right? It fitted speakers inside the car, and these speakers would give the sound of a V10 engine. So every time you stepped on the throttle slightly, you would have a slight whir. The moment you went harder, instead of listening to that three-cylinder, and three-cylinder engines are horrible to listen to, so instead of listening to the three-cylinder sound, you can hear a V10 engine at the back of your car. What can you complain about, right? Whereas the motor and the engine are doing a fantastic job of giving you a very similar performance. So that is what BMW did. And now Teslas they are the rule breakers, right? You have Elon Musk, who is a genius, but a very scary genius. Uh, so, what Teslas have is they have external speakers. Forget internal speakers. They have external speakers which are there to provide sounds and make people around you aware that, a car is approaching them. But again, there is a hack where you go into your Tesla touchscreen. There is a couple of steps that you break into the system, and you can literally play any sound you want. So you could have ducks quacking the faster you go. So that is another, crazy thing that Tesla has done over these ages. So yes, this would conclude our webinar. So okay, Rashmita has a question. Good afternoon. What is the rolling resistance for EV, and how is it compared to gasoline-based vehicles? Rashmita, the rolling resistance would be slightly higher because of the higher weight. No other difference, because again, you are talking about four wheels running on the road, so not a big difference when it comes to rolling resistance. So yes, any questions does anyone have?
Sir, I have a question.
Yeah, Harsha.
The very first slide you're talking about that and putting the battery underside of the vehicle, right? The lower side of the vehicle.
I didn't get you. Just repeat. Slightly slow.
You're placing the battery at the lower side of the car, right?
Yeah, yeah, yeah,
So
yeah.
when we moving on the very rough terrains, for example, due to fatigue, is there any chance of battery getting loosened up or getting falling down, something like that? I
Okay,
heard
so see,
something like this.
yeah, that now, okay, so we need to understand. We are actually a very spoiled generation, right? We have been given everything, the best of everything. To be honest, we were not there to see the start of the IC engine. We were not there to see how many IC engines actually fell off a vehicle while driving. So there are many things that we yet do not know about batteries, which are going to come up ever so slowly. But we do have a lot of things on our side this time, where we have got a good amount of CAD CAM technologies where we can process things before they can actually happen. And then we've got a very good understand of the FOS, or the factor of safety, that we are going to design for. So that is going to be really helpful for us, and that is what we have going for us over here.
Yes, sir, got it.
Yeah, so it can happen. I'm not going to say it will not happen, especially with the fireworks that are going on very recently across various manufacturers. And then there are things that we yet have to learn. Are anti-roll bar necessary? On which act does EV runs? Does it follow? Mohammed Salman, I am not a lawyer, man. I cannot help you with which act it runs on. Yeah, next
Welcome,
question
welcome.
is, anti-roll bar necessary in electric vehicles? Yes, Aditya, why not? Anti-roll bar is a very simple thing, but such an important feature in a vehicle that not using it would be stupidity at one point of time, until unless you have got active suspension, which is kind of expensive to install as of now. Does EV also have BS versions? Nope, they do not. Not that I know of. What do you think that Riven EV pickup truck manufacturer provided quad motors in order to have better CG for better performance? So Motkuri, okay, so Shiva again. So yes, okay, so I've not heard of the company, but if you're going to tell me that there's one motor for each individual wheel, that's the best. Why not? You have an all-wheel drive vehicle, and it's very easy to do that with EVs. Of course, the cost will go higher, but it's than it is with IC vehicles, where you do not have to have a transfer case and have mechanical coverages handling things like that. You will not even have mechanical breakages at that point of time, right? So yes, for having all four wheels driven is any day better than having two wheels driven. uh, okay, my question regarding battery safety in flood situation. Chandragrup, good question, man, really good question. Flood situations, let's just say it's going to be safe. And again, the same answer that I gave Harsha, there's yet lot of things that we have to learn. See, we didn't know that when you take an IC engine into a flooded, road, and if you let go of the throttle, you would have vacuum being created into your exhaust pipe, which will suck in the water. Sometimes if the vacuum pressure is so much, it sucks in the water all the way in, till your engine headers, right, and will stall your vehicle completely, or maybe just clog your entire catalytic converters and things like that. So there are a lot of things that we yet have to learn. They are saying that it is safe. You also have phones that are waterproof, right? You have watches that are waterproof, but they also come with an asterisk, right, at the end of it, कि इतना ही meters तक लेके जा सकते हो. Maybe something similar that we could look at over here. It would be slightly better than IC engines if everything can be insulated to that degree. um, Google is also not providing information, sir. See, Salman, currently the state of EV technology and EV development is such that everyone around the globe is working on different things at the same time. People are coming up with hypotheses and rejecting hypotheses at the same time. So confirmations will come out slow, but starting off and getting onto this trend and actually focusing, especially the place where you guys are, where you are just leaving college or are about to leave college in the next 1 2 3 whatever amount of years, it's going to be essential that you guys, start learning about this, start paying attention to all of these things, right? So by the time you enter the industry, you would already be equipped. You just take few moments to learn, okay, what's the latest thing that is there, and then you can start working from there, rather than going back and then learning what people have done in the last 20 years and stuff like that. You do it while you are in college. The moment you leave college, you are ready to go and rock the world, right? Safety of battery in EV because of induced vibrations if we have typical ladder chassis. So Mohammed, Anshal, right? So see, basically, when you are talking about induced vibrations, you can always have it damped out. And battery pack technology, battery pack design is not an easy thing to crack. You start with a battery pack design course today, and 3 months from now also, you most probably won't be done with it. You would have a better understanding, but you would be nowhere close to mastering it. And the reason for that is you need to take into consideration vibrations, and especially when we are going to talk about twisting, chassis twisting, your battery pack needs to be strong enough to resist that. So you would be having members inside your battery pack itself to provide the battery pack with the required safety, thus providing your vehicle with the safety that a cross member would provide. Can you explain regenerative braking a little deeper? Okay, I'll do that. Is disposable batteries are major issues? Raj, actually, that is a big issue right now, where people do not are looking forward to having stuff that can be maintained much easily, rather than disposing the batteries, because of course that will lead to a lot of waste and harm the environment. Okay, Bhargav, so how do you supercapacitors in EVs because of the instant? Bhargav, I cannot comment on that. Again, I am from the mechanical field. I have not ventured that much into the drivetrain part of an EV. For suspension system of electric vehicles, Aditya, so designing a suspension system is mostly reaction. It is you don't design the suspension first and then design the get the motor and everything. So after you have got all of your parameters set, what kind of vehicle you're building, and the approximate CG that your vehicle will have, the overall weight that will be there, the number of people that your vehicle is designed for, where the weight transfer and the weight is going to be, so that you can calculate the weight transfer. That's when you get into the suspension system. Okay, so Mohammed Iqbal wanted to know about regenerative braking. So it's simple. So rather than having a motor and a generator separately, you have got a motor generator unit, right? So what this motor generator unit does is it provides the rotational force. It gets your vehicle into motion. Now, the moment you lift off the accelerator pedal, your wheels are free rolling, right? And now the car understood, okay, if you let off the gas, that means you do not need power. So it will start using the inertia that your vehicle has. So if you have ever heard of something called as engine braking, this is something that most experienced drivers as well as race drivers do.
A very
Rather
good
than
evening, one and all
putting
present
all of the
here.
braking
I
force,
welcome you
braking
all in the
requirement
closing
onto
ceremony.
their